Whole galaxies can quietly stop making stars and then fade away. That means billions of stars stop being born, and the galaxy slowly grows dimmer. Think of a city that never builds new houses. A galaxy without new stars ages, and its light shifts to redder colors. You should care because star formation shapes everything we see in the sky. This video shows how galaxies die, why it happens, and what that tells us about the universe. Quick recap: some galaxies die because they stop forming stars, and they slowly fade. Picture a spiral galaxy, blue arms full of newborn stars. Star formation refers to the birth of new stars from cold gas. This matters because new stars keep galaxies bright and chemically evolving. Cold gas collapses under gravity, and it fragments into dense cores that ignite nuclear fusion. Supernovae and stellar winds can both trigger and halt more star formation nearby. For example, the nearby galaxy M33 shows bright star-forming regions across its arms. Bottom line, star formation depends on cold gas supply and local feedback processes. Now imagine that gas supply slowly dries up over billions of years. Gas starvation means galaxies lose access to fresh cold gas. You should care, because without new fuel, star formation grinds to a halt. Gas can stop arriving because large-scale cosmic filaments shift and the galaxy's gravity weakens. Hot halos can form, and they prevent cold gas from cooling and settling into the disk. A concrete case is massive elliptical galaxies, which lack cold gas and show old stellar populations. So the picture is simple. Without renewed gas, galaxies slowly stop making stars. Think about a black hole gobbling everything at a galaxy's center. Active galactic nuclei blast energy out, and they heat surrounding gas. This heating prevents gas from cooling, and it chokes off star formation. The stakes are huge because this process can quench entire galaxies in a short cosmic time. Jets and winds from the central black hole push gas away, and they stir the remaining gas into hot, diffuse halos. Observations of radio galaxies show massive jets aligned with cavities in hot gas. Net result: black hole feedback can rapidly stop star formation across a galaxy. Picture a galaxy falling into a larger cluster and feeling the wind. Ram pressure stripping sweeps gas out, and it leaves the galaxy gas poor. This matters because environment determines fate, and many galaxies live in dense clusters. The intracluster medium exerts pressure as galaxies move through, and it strips the cold gas from their disks. Observations of jellyfish galaxies show trailing tails of stripped gas and star formation knots. What to remember: interactions with the surroundings can physically remove star-forming fuel from galaxies. Visualize a disk becoming a smooth, puffy bulge, and the gas settles differently. Morphological quenching happens when galaxy structure suppresses star formation. You should care, because internal changes can doom star birth even if gas remains. A dense stellar bulge increases shear and stabilizes the disk against collapse, and gas cannot fragment easily. Simulations show disks with massive bulges form far fewer stars than thin disks. Bottom line: shape matters. A galaxy can choke on its own structure. Now look at the long fade of stellar populations once star formation stops. Aging stars grow redder, and the galaxy's light dims. This matters for observers because colors tell us a galaxy's history. Massive stars die quickly, within millions of years, and they no longer illuminate the galaxy. After a billion years, only smaller stars remain, and the spectrum peaks at redder wavelengths. Example: lenticular galaxies show old stars and weak emission lines, consistent with long-term fading. So the visible death is gradual and tied to stellar life cycles. Tiny test: how do astronomers tell a galaxy is dead or alive? They read light and measure colors and spectral lines. This is crucial because diagnostics reveal past star formation rates and gas content. Ionized gas emission indicates very recent star formation, and absorption features show older stars. Surveys like SDSS provide millions of spectra, and they classify galaxies as star-forming, transitioning, or passive. Final recap: astronomers use colors and spectra to time a galaxy's decline and death. We started with a shocking idea: galaxies can die and fade slowly. The key takeaway is that several processes stop star formation, and then galaxies age. Observations and simulations together reveal gas starvation, feedback, stripping, and structural changes at play. The cosmic story is that galaxies evolve, and many paths lead to a quiet end for star birth. If you remember one thing, it's this: galaxy death is common, and it teaches us about how structure forms in the universe. Thanks for watching, and if you enjoyed this, consider subscribing for more cosmic stories.